Episode 6. Title of the Radio Enabled Learning course is Energy Physics. Unit 2, Energy from Oceans. In this episode 6, now we will discuss about energy utilization of energy from the oceans. If possible, an OTEC plant should be less than about 30 km from shore. The electricity generated could then be transmitted inexpensively to land by submarine cable. At somewhat greater distance, the transmission cost would be increased but might be tolerable. If the plant is so far from shore that these costs become prohibitive, the electricity generated can be utilized at the plant site to produce energy intensive materials. One suggestion is to use direct electric current to decompose seawater by the process of electrolysis. The main products would be hydrogen and oxygen. The hydrogen could be liquefied and transported by tanker to a point where it could be used as fuel. Alternatively, the hydrogen could be combined with atmospheric nitrogen to form ammonia for use fertilizer, thereby saving natural gas, which is presently the main source of hydrogen for this purpose. In this utilization, first we would like to see hybrid cycle. There are several variations on the standard OTEC open cycle system. One variation is hybrid cycle, which is an attempt to combine the best features and avoid the worst features of the open and closed cycle. The heat in the resulting steam is then transferred to ammonia in an otherwise conventional closed Rankine cycle system. A comparative study of closed, that means ammonia, and open, that means steam, and hybrid cycle showed the closed cycle system to be most economical in the cost and to require the least parasitic power. Closed cycle is favored for the future development in expectation of higher efficiency, but does not yet have advantage of having put in practice. Compared with the prospects of wind power for large scale development to help meet out energy needs soon. It is this lack of experience that puts ocean thermal difference development at a disadvantage and leads to be on wind power. In the case of wind power, the favored method has been demonstrated practical in several countries over the past half century and has failed only the economic test in the era of cheap fuel, whereas the favored method of ocean thermal energy conversion has not been so demonstrated. It is to be hoped that it soon will be. There are reports that Japan plans to lead the way in actual development, research and actual development, particularly of materials, and overcome other problems, and also design are in progress in this country. Prospects of ocean thermal energy conversion in India. The OTEC project cell established at IIT Madras has completed the preliminary stage and study for establishing 1 megawatt OTEC plant in Lakshadweep Island at Minikai. The OTEC works on the principle of utilizing the temperature difference of the sea at depth and that at the surface sea water is used to vaporize a low boiling chemical which drive a turbo generator. The vaporized chemical is then compressed. It is condensed by using cold sea water from depth. Preliminarily, oceanographic studies on eastern side of Lakshadweep island suggest the possibility of the establishment of shore-based OTEC plant at the island with a cold water pipeline running down the slope to a depth of 800 to 1000 meters. Both the islands have large lagoons on the western side. The lagoons are very shallow with hardly any nutrient in the seawater. The proposed OTEC plant will bring the water from 1000-meter depth which has high nutrient value. After providing cooling effect in the condenser, a part of depth seawater is proposed to be the lagoons for development of aquaculture. A hydrographic survey of proposed site was undertaken by National Hydrographic Office, Dehradun. The preliminary assessment of survey indicates the availability of suitable conditions for establishment of OTEC plant. Next, we will discuss about energy from tides. Tide is a periodic rise and fall of the water level of sea which are carried by the action of the sun and moon on the water of the earth. Tide energy can furnish a significant portion of all such energies which are renewable in nature. It has been estimated that about 1,000,000 kilowatt of tidal power is dissipated by friction and eddies alone. This is slightly less than the economically exploitable power potential of all the rivers of the world. It is only indication of magnitude of tidal power available. All of it's not economical feasible also. The first attempt to utilize energy of the ocean was in the form of tidal mill in the 11th century in Great Britain and later in France and Spain. The large-scale up and down movement of sea water represents an unlimited source of energy. If some part of this vast energy can be converted into electrical energy, it would be an important source of hydropower. The main feature of tidal cycle is difference in hydropower. The main feature of tidal cycle is the difference in water surface elevation at the time tide and at the low tide. If this difference head could be utilized in operating hydraulic turbine, the tidal energy could be converted into electrical energy by means of attached generator. In principle, this is not very difficult as water at the time of high tide is at high level and can be let into a basin to be stored at high level there. The same water can be let back into the sea during the low tide through the turbines, thus production of power. Since the basin water level is high and sea water is low, there is differential head comparable to tide range that can be utilized for running of turbines. Basically, it appears to be simple proposition. The problem involved in it are many. The tides, as we see, although free, were inconvenient because they come at very times from day to day, have varying range, that means heads, and for a large output required large capital expenditures. Their yearly use declined and came to the off with the coming of the age steam and cheap coal. With the beginning of energy crisis in 1970s, the tidal energy, like other renewable energy sources, received renewed attention. The first tidal power plant was commissioned by General de Gaulle at Lawrence in 1966, which marked a breakthrough. The average tidal range is 8.4 meter and the maximum is 13.5 meter. Effective basin surface is 22 km square. Basin volume is 184,000,000 meter cube. There are no special problems with this site and it was very sensible choice for the world's first tidal power station. It has used a single basin and submerged reversible propeller type turbine generators that could be generate power with the water flowing in either direction through the turbine runner. Bulb turbines have been provided in the project. They are operating satisfactorily for the last 25 years. The dam contains a small lock of commercial vessels, 6 movable gates and 24 turbo generators units of 10 megawatt each. The movable gates are used to accelerate filling the emptying of the storage basin at small differential water levels. Installed capacity of 240 megawatt, but of course the average power generating capacity is less because power can be generated only intermittently. Maximum electric energy production capacity is 544,000 megawatt hour per year, which gives a plant capacity factor without any allowance for maintenance or downtime of 0.26. Maximum utilization of the stored hydraulic potential energy is 18%, which may be increased to 24% in future by additional of 80 megawatt more generating capacity. There are presently 2 tidal power stations operating. One is France and one is in the USSR. The one is France is full commercial station. The one is the USSR is more in the nature of pilot plant engineering experiment and is rather small in size. The French project at Reims near Saint-Malo in Brittany uses a dam that goes straight across the estuary of Reims River. The dam is not too long, 750 meters shore to shore. The depth is never more than 12 meters below mean sea level. There is an above surface rock pot way across. The climate is moderate. Kisoloya Kuba on the Barents Sea, 70 km northern part of Murmansk. It is small and was intended as pilot project. It has one generator of 400 megawatt rating and delivers 700 to 800 megawatt per year to the local electrical grid. Operating began in 1968. Nearly for 17 years there was a dull period in the tidal power development due to the problem involved in it. The main disadvantage of tidal power plant is that the production of power from tidal station occur at times and in magnitude which are dependent on the relative position of Earth, Moon and Sun to one another and not on the electrical demand of consumer. The success of Lawrence stimulated interest in Canada, where on the eastern coast in the Bay of Fundy. The largest tidal ranges in the world occur begin as high as 16 meters on spring tides. The pioneer project in Nova Scotia, Canada at Annapolis Royal was commissioned in 1983. For the first time, conventional bulb turbines were replaced by large rim generator units of turbines with runner diameter of 7.6 meter and capacity of 10 megawatt. Through this type of turbine has been in use for many years in Europe. Its runner diameter was limited to about 2 meter by ceiling problem at the runner is end of the project. If this proves successful, it will be provide an attractive alternative to the bulb unit, since the Strafa flow unit has much higher inertia, thus enhancing system stability and access the generator easier, thus facilitating maintenance. In India, there are possible tidal projects in Gulf of Quds and Cambay, and on smaller scale in the Sandabas regions of the Bay of Bengal. In Korea, there are a series of studies by Canadian and French firms, the latest one being of Garolim Bay. The comparative statistics of some recent proposed tidal scheme are: in UK, installed capacity is 7,200 megawatt. Indian Gulf Quds Candela is 600 megawatt. Korea is 480 megawatt. Brazil is 30 megawatt. USA is 2220 megawatt. Canada is 1147 megawatt. China is only 3 megawatt. USSR is 10,000 megawatt. These are some important statistics of some recently proposed schemes. Tides are produced mainly by the gravitational attraction of the moon and the sun on the water of solid earth and the ocean. About 70% of tide producing force is due to the moon and 30% of sun. The moon is thus the major factor in the tide formation. Surface water is pulled away from the earth on the side of facing the moon, and at the same time the solid earth is pulled away from the water on the opposite side. Thus high tides occur in these two areas with low tides at intermediate points. As the earth rotates, the position of a given area relative to the moon changes, and so also do the tides. There are a periodic gap of high and low tides. Although there are exceptions to tide cycle, that means 2 high tides and 2 low tides occur during a lunar day of 24 hours and 50 minutes. The lunar day is the apparent time of revolution of the moon about the earth. That is to say, the time between high tides and low tides at any given location is little over 6 hours. A high tide will be experienced at a point which directly under the moon. At the same time, a diameter opposite point on the earth's surface also experience a high tide due to their dynamic balancing. Thus, a full moon as well as a no moon produce high tide. In a period of 24 hours 50 minutes, there are therefore 2 high tides and 2 low tides. These are called semi-diurnal tides. The rise and fall of water level follows a sinusoidal curve, shown with point A indicating the high tide point and point B indicating the low tide point. The average time for the water level to fall from A to B then rise to C is approximately 6 hours 12.5 minutes. The difference between high and low water level is called the range of tide. The tidal range R is defined as capital R is water elevation at high tide, water elevation at low tide. Because of the changing position of the moon and sun relative to the earth, the range varies continuously. There are, however, some characteristics feature of this variation. At times near full and new moon, when sun, moon and earth are approximately in a line, the gravitational force of the sun and moon enhance each other. The tidal range is then exceptionally large. The high tides and higher and low tides are lower than the average. These high tides are called spring tides. On the other hand, near the first and third quarters of the moon, when the sun and the moon are at the right angle with respect to the earth, neap tides occur. The tidal range is then small. The high tides are lower than the low tides, higher than the average. Hence, the range is not constant. It varies during the 29.5 days lunar month, beginning maximum at the time of new and full moon, called the spring tides, and minimum at the time of the first and third quarter moons, called neap tides. The spring neap tidal cycle lasts one of a lunar month. A typical mean range is roughly one-third of the spring range. The actual variation in the range are somewhat complicated by seasonal variation caused by ellipticity of the Earth orbit around the Sun. The variation in the periodicity and monthly and seasonal ranges must, of course, be taken into account in design and operating tidal power plants. The tides, however, are usually predictable and fairly accurate tide tables are usually available. Tidal ranges vary from one Earth location to another. They are influenced by such conditions as the profile of local shoreline and water depth. When these are favorable, as resonance like effect causes very large tidal ranges. Ranges have to be very large to justify the huge cost of building dams and associated hydroelectric power plants. Such tides occur only in few locations in the world. Following points have to be specially noted in connection with the tidal phenomenon. First one is, the tides are periodical phenomena, but no two tides in any cycle are alike. Since the relative position of sun and moon and their distance from the earth continuously changing, the tides are also influenced accordingly. Of the two high tides in a single day, one tide is higher than the other. In any month, the tides on the full moon and no moon days are particularly higher than the rest, as on these days suns and moons attractive acts indirect or direct additive manner. These are termed as spring tides. In any year, the tides that occur at the time of is related to location of the sun and the earth. Thus the tidal range capital R shown in very clear manner, generally a long time mean value. Capital R is designated as mean tidal range at any particular place. The second one is, the mean tidal range varies from place to place. The shape of a tidal cycle depends upon interaction of the sea with the coastal line. Where the coastal line offers a resonating influence, the tidal range get high and low. At the other places, the land may produce dampening effect on a tidal phenomena. Because of this interaction effect, the tidal range varies from place to place. Third one is, in spite of their complexity, the tides are amenable to the mathematical analysis. As a result, the exact time and the water level for a high tide as low tide can be forecast with great accuracy. Thus the tidal phenomenon is a unique feature of every coastline. Thank you.